Hello everyone, welcome back. You are in my channel Ramakrishna Math Zone. See, today I'll discuss about chapter 2 and that is conditional probability and Bayes theorem. I already told you in the lecture 1 that मैं follow कर रहा हूँ कौन सा बुक, प्रसन्न साहू सर का बुक. ठीक है, ये बुक से आप बेसिक से सीख सकते हो कि इधर का लैंग्वेज कोई भी डिफिकल्ट नहीं है, मतलब इजी टू रीड है. फिर भी मैं ऐसे कर रहा हूँ कि वन बाय वन किसके बाद मतलब कौन सा पार्ट पहले स्टार्ट करना है, उसके बाद क्या पढ़ना है, ऐसे कंटिन्यूअस वे में मैं प्रोसीड कर रहा हूँ. उनका हर एक चीज का एग्जाम्पल भी डिस्कस करते जा रहा हूँ ताकि आपको इजीली समझ में आए. ठीक है ना. कंडीशनल प्रोबेबिलिटी दिखने में कैसा है कि प्रोबेबिलिटी ऑफ ए गिवन बी, दैट इज क्या, द नंबर ऑफ एलिमेंट इन ए इंटरसेक्शन बी बाय the number of element in B, the number of elements in B. So इसको लिखोगे कैसे? Probability of A given B, you can write this like in this way. Probability of A given B, that is equal to probability of A intersection B by probability of B. Probability of A by A given B is equal to probability of A intersection B by probability of A by B. This is the formula. Now it comes, how it comes? See, from this expression we can write probability of A given B equal to number of element in A intersection B. ठीक है, by number of element in B. Now what we can do from this, probability of A by A given B equal to number of element in A intersection B by number of element in sample space. Sorry, S. Sample space is S. We already know in the last class what is sample space. So this. ठीक है. Provided n is not equal to 0. ns क्या है? नंबर ऑफ एलिमेंट इन एस. ये क्या है? नंबर ऑफ एलिमेंट इन सैंपल स्पेसेस. सैंपल space is, okay, number of element in sample spaces. Okay, now from this, ये provided था, इसको मैं बॉक्स में लिख दिया. Now that implies probability of A by A given B is probability of A intersection B by probability of B. That is the final scenario. This, okay. Okay, this is the final scenario. Now where provided probability of B greater than 0. Okay, probability of B 0 नहीं हो सकता. 0 होगा तो डिनोमिनेटर 0 होगा तो प्रॉब्लम हो जाएगा. ठीक है, तो कंडीशनल प्रोबेबिलिटी, जो प्रोबेबिलिटी ऑलरेडी गिवन है वो कभी 0 नहीं हो सकते. ठीक है. नाउ वन डेफिनेशन इज देयर. The definition is, one definition is there. The definition is what? Now definition is given that let S be a sample space ठीक है, associated with the random experiment. Random experiment. Okay, the conditional probability of an event A event A, the conditional probability of an event A given that the event B has occurred is defined by this. Now this is the definition, proper definition, defined by probability of A given B equal to probability of A intersection B by probability of B. Okay, this is the definition. Provided probability of B greater than 0. ठीक है? Okay. This conditional probability measure, this conditional probability measure, conditional probability measure means probability of A by B, that is probability of A by B satisfies all three axioms of probability. Lead. Okay, that is कौन सा प्रोबेबिलिटी सेटिस्फाई करेगा? एक तो नंबर 1 ऐसा है कि प्रोबेबिलिटी ऑफ ए गिवन बी इज ऑल्सो ग्रेटर और इक्वल टू 0 फॉर ऑल इवेंट ए. ओके, दूसरा है प्रोबेबिलिटी ऑफ बी गिवन बी इक्वल टू 1. या ऑफ कोर्स, कैसे प्रूव करोगे? यू कैन प्रूव योर सेल्फ बाय डेफिनेशन, राइट. थर्ड है इफ A1 A2 डॉट डॉट करके AK एंड डॉट डॉट करके और इंफिनिटी तक आर म्यूचुअली एक्सक्लूसिव इवेंट then probability of union k equal to 1 to infinity AK by B equal to k equal to 1 to infinity probability of AK given B. Okay, that's the final one. According to that same प्रोबेबिलिटी के लिए जो था, प्रोबेबिलिटी नॉर्मल प्रोबेबिलिटी इवेंट के लिए जो था, यहाँ पे कंडीशनल इवेंट के लिए बस एक्सटेंड करके रखा है. ठीक है, ठीक है. दिस इज द सिनारियो. ओके, नाउ आई थिंक आई कैन डिस्कस अबाउट वन एग्जांपल. yes, we can think about one example. If I choose, see, example I will discuss with you. Example, if we randomly pick two television sets, in succession from a shipment, of 240 television. Set of which of which 15 are defective. Try to understand my question first. After that you can easily solve. Defective. What is the probability that what is the probability that they will be both defective? They will be both defective. What is the probability? Okay, this is the question. So how you can solve this question? How you can approach basically? Okay, so we randomly pick 2 television sets in succession from a shipment of 240 television set, of which 15 are defective. So out of 240, 15 are defective. So that probability of they will be both defective. See, that is the question, important question. They both are defective means how you can approach? See, we can consider, let A denote the event that the first television picked was defective. Let B denote the event that the second television picked was defective. Got my point? I define like this. Defective. Basically we denote. Then what we need to calculate basically? Tell me. We need to calculate probability of A intersection B. Probability of A intersection B equal to what? So we know probability of A we know. See, try to understand. Probability of A we know. Denote that first television is defective, that is 15 out of 240. Okay, got my point? 15 out of 240 you know. Okay, since you know, so we use that formula, probability of B given A equal to probability of B intersection A by probability of A. ये जो फॉर्मूला है इसको यूज करोगे तो probability of A intersection B means probability of B intersection A, that is equal to probability of B given A into probability of A. Now that is equal to probability of A into probability of B given A. ठीक है, ये हो गया. That is हम क्या कैसे बोल सकते हैं? देखो, probability of A is 15 by 240, that is fine. Probability of B given A is, that is 14 by 239. How? That is the big question. How? I will explain you. See, into sorry, यहाँ पे पहले कैलकुलेट कर देते हैं 239. तो बेसिकली ऊपर में हो जाएगा 15 इंटू 14 बाई नीचे हो जाएगा 240 इंटू 239. इसको सिंप्लीफाई करोगे तो आंसर आ जाएगा. ठीक है, इट्स फाइन. नाउ क्वेश्चन इज हाउ प्रोबेबिलिटी ऑफ बी गिवन ए इज. प्रोबेबिलिटी ऑफ ए इज 15 by 240. Okay, that means first television is defective. Now probability of B given A is see we already know first elevation is defective. A given means there are कितना टोटल इवेंट है 240 में से 1 माइनस कर दिया जाएगा एंड उनमें से कितना डिफेक्टिव हो सकते हैं 15 था उनमें से एक चूज कर लिया गया तो कितना बचेगा 15 माइनस 1 यू गॉट माई पॉइंट दैट्स व्हाई 14/239 okay that's the scenario okay you got my point that is basically our rough work for your understanding yeah this is the final answer okay I think in this way if I try to discuss with you that is clear for you as well and I think that is more effective for those students who are try to learn probability first time okay probability is not difficult but for probability advanced level things I think they are difficult not that much but it's okay but these basic probability statistics parts are very easy try to just visualize all those things properly after that it is quite easy definition one more definition is that two events A and B. Two events A and B of a sample space S are called of a sample space S are called independent. If and only if आप इसको शॉर्ट में इफ एंड ओनली भी लिख सकते हो क्या प्रोबेबिलिटी है इवेंट्स आर independent means probability of A intersection B is probability of A probability of B that is it okay very important you need to use it many places okay this is the definition now for you एग्जाम्पल दे दूं नहीं उसको छोड़ो अच्छा एक थियोरम दिखाता है एग्जाम्पल तो एक दिया था अभी एग्जाम्पल के ऊपर नहीं डिस्कस करेंगे एक थियोरम देख लेते हैं थियोरम बोल रहा है कि लेट ए बी सबसेट ऑफ एस मीन सैंपल स्पेस का सबसेट है इफ ए बी आर इंडिपेंडेंट इफ ए एंड बी are independent if A and B are independent and PB greater than 0 then probability of A given B is probability of A proof क्या है इजी है proof बहुत ही इजी है क्या है probability of A given B means क्या probability of A intersection B by probability of A now since A and B are independent so since probability of A intersection B equal to what probability of A into probability of B probability of A into B that is use this formula so that implies probability of A probability of B by probability of A ठीक है सॉरी probability of B ना B गिवन था तो नीचे B होगा गॉट इट तो नाउ probability of B भी कट जाएगा तो बचेगा probability of A क्यों कट सकते हैं क्योंकि probability of B गिवन था greater than 0 so it is not an issue at all so we can proceed in this way okay so proved we are done okay now another interesting concept very easy result theorem easy result कि if A and B are independent events if A and B are independent events then A complement and B are independent, and B are independent. Okay, A complement and B are independent. Similarly, you can prove that A and B complement are independent as well. Well, prove. ठीक है, तो इसको कैसे प्रूव किया जाए? इसको कैसे प्रूव किया जाए? Proof. We know that A and B are independent. A and B are independent. So probability of A intersection B equal to probability A probability B. It is given. ठीक है ना, इसको मैं बॉक्स कर लेता हूँ, इसी को यूज करूंगा भाई. Now probability of A complement intersection B equal to, we can write in this way, probability of A complement given B into probability of B, right? In this way we can write. So that implies 1 minus probability of A given B into probability of B. That is equal to probability of B minus probability of A given B probability of B. That is equal to probability of B minus probability of A intersection B. Now A B are independent means probability of B, ये 1 नंबर दिया, तो यहाँ से मैं बोल सकता हूँ कि माइनस प्रोबेबिलिटी A प्रोबेबिलिटी B बाय 1 से हम बोल सकते, दैट इम्प्लाइज प्रोबेबिलिटी ऑफ B 1 minus probability of A. That is equal to probability of B probability of A complement. You know na, probability of A complement equal to 1 minus probability of A. I use those results, that is equal to probability of A complement probability of B. This side क्या होगा, probability of A complement intersection B equal to this. That implies A complement and B are independent, right? Independent. Similarly, you can do other part. Similarly, you can easily prove other part. अदर पार्ट आपको प्रूव करना है, आप इजीली कर सकते हो. ट्राई टू डू योर सेल्फ, इट इज क्वाइट इजी. सो आई स्किप इट एज एक्सरसाइज. ओके ओके. अच्छा, one theorem is there. Theorem statement is given that suppose two possible mutually exclusive events are always dependent. That is the statement basically. Two possible mutually exclusive events are always independent. प्रूफ कैसे करोगे इसका प्रूफ? इसका प्रूफ करने के लिए आपको क्या करना पड़ेगा? सपोज नॉट, मतलब जो गिवन है वो सही नहीं है। देन प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी इक्वल टू प्रोबेबिलिटी ऑफ ए प्रोबेबिलिटी ऑफ बी। म्यूचुअली एक्सक्लूसिव मीन्स क्या? प्रोबेबिलिटी ऑफ ए इंटरसेक्शन बी मीन्स एमटीटी इक्वल टू प्रोबेबिलिटी ऑफ ए प्रोबेबिलिटी ऑफ बी। गॉट माई पॉइंट? दैट इम्प्लाइज that is 0 equal to probability of A probability of B. Mutually exclusive means A intersection B equal to empty, right? Empty, that implies either probability of A equal to 0 or probability of B equal to 0. Either this is equal to 0 or this equal to 0. That implies we get contradiction to the fact that A and B are possible events. So they are events, so how their probability is 0? मतलब they are possible events, so how their probability 0? Never ना। possible events एटलीस्ट कुछ तो होगा, कुछ पॉजिटिव नंबर होगा, 0 नहीं हो सकता। देयरफॉर वी आर डन। हमारा जो एजम्पशन था वो रॉन्ग है, मतलब जो गिवन स्टेटमेंट है वो सही है। सो प्रूव्ड। ओके, इन दिस वे यू कैन अप्रोच दिस थिंग्स क्वाइट इजी। ओके ओके ओके, नाउ we mainly focus on the main theorem, that is Bayes theorem. Now we are moved towards Bayes theorem. Now we are moved towards Bayes theorem. Okay, what this theorem states? See, before this we need to know another result actually, that is known as total probability. See, Bayes theorem तो जानोगे, उससे पहले मैं राइट साइड में लिख रहा हूं, that is known as total probability. Total probability. What is this? टोटल प्रोबेबिलिटी है क्या बेसिकली? ठीक है, आई विल डिस्कस। सी, इफ द इवेंट्स बी आई इक्वल टू 1 to m constitute a partition of the sample spaces. S and PBI not equal to 0 for I equal to 1 to ... करके m, then for any set S, any event A in S, any event A in S, probability of A is equal to probability of BI probability of A given BI, that is known as probability, and I varies from 1 to m. Okay, that is known as the formula of total probability. Okay, that is the known as formula of total probability. Okay, now you can, okay, I can prove these things. No need to prove. Prove yourself. Prove. Exercise for you. Exercise. Try yourself. Now I state the theorem, that is known as बेस थ्योरम। बेस थ्योरम का स्टेटमेंट बोल रहा है इफ द इवेंट बी आई इक्वल टू 1 to m constitute a partition of the sample space F sample space S and PBI, probability of BI not equal to 0 for those all I dot dot करके m तक, then for any event A in S such that probability of A not equal to 0 is probability of BK given A equal to probability of BK probability of A given BK by I equal to 1 to m probability of BI probability of A given BI, where k is equal to 1 to dot dot करके m। ओके, नीचे ये जो टर्म है, रुको वेट, नीचे ये जो टर्म है, ये जो नीचे टर्म है इसको बोलते हैं टोटल प्रोबेबिलिटी, इसको बोलते हैं टोटल प्रोबेबिलिटी। ओके, सॉरी क्यों प्रॉब्लम हो रहा है, अच्छा टोटल बिलिटी, ठीक है। तो दिस ऑन द सिनेरियो। नाउ I will discuss the proof of this theorem. Yeah, we can prove. अच्छा, okay, statement we need. This is the statement. So इसका प्रूफ जब करोगे, प्रूफ करने के लिए क्या करना है कि using the definition of conditional probability we are done. Using the definition of conditional probability, conditional probability. By the definition of conditional probability, probability of BK given A is probability of BK intersection A by probability of A equal to probability of A intersection BK by probability this by summation I equal to 1 to m probability of BI probability of A given BI। ओके, नीचे टोटल प्रोबेबिलिटी हो गया, एंड ऊपर में जो टर्म है उसको हम लोग ऐसे नहीं लिख सकते क्या, प्रोबेबिलिटी ऑफ BK probability of BK probability of A given BK लिख सकते हैं बिल्कुल, दैट इज बाय I इक्वल टू 1 to m। ये टर्म कहां से लिखा, ये टर्म बाय डेफिनेशन ऑफ टोटल प्रोबेबिलिटी, बाय डेफिनेशन ऑफ टोटल प्रोबेबिलिटी। सो इसको हम लोग बाय डेफिनेशन लिख दिया, देयरफॉर that is equal to probability of BI probability of A given BI, ठीक है, that implies probability of BK given A। प्रूव्ड, वही प्रूव करना चाहिए था और प्रूव तो हो ही गया, ठीक है ना, गॉट माई पॉइंट। Okay, Bayes theorem is done. Now what we can do? Bayes theorem is already done. Now what we can do? One example for Bayes theorem. One example for Bayes theorem, that is enough, I think. Okay, I will discuss one example of Bayes theorem. Okay, see, one any, I think from any book we can choose this example. Okay, no problem at all. Okay. Example. Bayes theorem example. Actually, I need one small example, no complicated example I need at all, because I just try to visualize the approach only, nothing else. So, if there is some small example, that is easy for me. Okay. Okay, I can choose. One minute. See, I provide you some basic example, actually no complicated example we needed at all. Bayes theorem को अप्लाई कैसे करते हैं वो सीख जाओगे. तो दिस चैप्टर में जो कंडीशनल प्रोबेबिलिटी एंड टोटल प्रोबेबिलिटी वाला पार्ट है वो सब सीख गए हो. एंड आफ्टर दैट बेस थ्योरम. दिस इज चैप्टर 2 अकॉर्डिंग टू आवर प्रसन्न साहू सर बुक. सी, मैं एग्जाम्पल ऐसे चूज कर रहा हूं. ए बॉक्स contains, try to understood my example, contains 3 red balls and 2 blue balls. Another box contains 4 red balls and 6 blue balls. Okay, one of the two box means दो बॉक्स में से कोई एक बॉक्स. one of the two boxes is chosen at random. And then one ball is drawn from it. If the ball drawn is red, what is the probability that it can come from first box? It can come from first box. Important problem, easy problem at all. See, again I try to read. A box contain 3 red balls and 2 blue balls. Another box is there that contain 4 red balls and 6 blue balls. One of the 2 boxes is chosen at random and then one ball is drawn from it. Okay, right, got my point? One ball choose किया then drawn किया. ठीक है. If the ball drawn is red, what is the probability that it is chosen from first box? So now we define something. See, let B1 first box chosen. First box is chosen. Okay, अच्छा. Next, B2 second box is chosen. Box is chosen and R red ball drawn. Okay, that's the scenario ना. फर्स्ट बॉल से लिया, सेकेंड बॉल से लिया और रेड बॉल. ठीक है ना. अच्छा, रैंडमली चूज गया ना. सिंस द बॉक्स नहीं, ए बॉक्स होगा. ए बॉक्स इज chosen at random, right? Randomly choose किया, chosen at random. Therefore probability of B1 equal to 1 by 2 and probability of B2 is also 1 by 2. Randomly choose किया तो दोनों को सेम सेम देना पड़ेगा ना. Now probability of R given B1 is 3 by 5. या B1 बॉक्स से रेड बॉल उठाने का प्रोबेबिलिटी क्या, 3 by 5. क्यों? यहाँ पे देखो 3 रेड बॉल है और 2 ब्लू बॉल है, तो टोटल बॉल नीचे होगा, ऊपर में रेड बॉल होगा. ऊपर में रेड बॉल, नीचे होगा टोटल बॉल. तो दैट इज ऊपर में 3 है, नीचे 3 + 2 है, दैट्स वाई 3 by 5. ठीक है. अच्छा, प्रोबेबिलिटी ऑफ R B2 दैट इज 4 by 4 + 6. ऊपर में रेड बॉल, नीचे रेड प्लस ब्लू बॉल मीन्स 10, तो दैट इज 2 by 5. दिस इज द सिनेरियो. ठीक है, ये दोनों आ गया. बट अकॉर्डिंग टू द गिवन क्वेश्चन we need probability of B1, मतलब probability of chosen from B1 given that the ball is red. What is this? We need this one. ठीक है. Now use Bayes theorem. By Bayes theorem, you got my point. Our question is what? The ball drawn is red. What is the probability it comes from first box? फर्स्ट बॉक्स से आ रहा है. इट इज गिवन दैट द बॉल इज रेड. सो बाय बेस थ्योरम व्हाट इज द सिचुएशन? बेस थ्योरम व्हाट वी कैन राइट नाउ? वी कैन राइट प्रोबेबिलिटी ऑफ B1 given R is equal to probability of B1 probability of R given B1 by नीचे probability of B1 probability of R given B1 plus probability of B2 probability of R given B2. ऊपर में क्या होगा? probability of B1 क्या होगा? 1 by 2. probability of R given B1 क्या होगा? 3 by 5. देखो ऊपर में थोड़ा सा स्क्रॉल करे तो दिख जाएगा. देखो probability of B1 हाफ है, B2 भी हाफ है, R given B1 3 by 5 और 2 by 5 है. सो ये हो गया. तो B1 हाफ है, इट इज 3 by 5 है, और प्रोबेबिलिटी ऑफ B2 ऑल्सो हाफ है, प्रोबेबिलिटी ऑफ R given B2 2 by 5 है. तो ऊपर नीचे मल्टीप्लाई करोगे तो ऊपर में 3 बच रहा है, नीचे 3 + 2 बच रहा है, तो आपका आंसर हो जाएगा 3 by 5. 3 by 5 इज द आंसर. सो फाइनली आप अच्छे से लिखोगे तो कैसे लिखोगे? द प्रोबेबिलिटी दैट the red ball came from the first box is 3 by 5. That's the answer. Okay. Hopefully you like this solution approach, and this lecture series you definitely like. If you feel that this lecture series is helpful for your any junior or any senior, for your classmate as well, please share and support. That give me some motivation to continue this type of video lectures. This playlist is completely free of cost for you for lifetime. please share and subscribe. Thank you.